Okay, so what I want to do is I want to just give, let me close my office door first. I want to give some sort of indication on how I expect, what I expect for the video portion of the exam. Now, I'm going to show myself solving the video portion of the exam on a whiteboard. If you have a whiteboard, that's fine. I imagine most of you don't, or I'm sure, those who are on campus can get to a whiteboard if you want to. You don't have to do that. If you have one, that's fine. What I would suggest most of you do is probably just start off, you get to upload a media recording, show a photo, not a photo of yourself, just record yourself, say, hey, I'm Rob, this is my solution to the exam or whatever, and then just set the phone or whatever you're using to record to just show your hands, and then you're going to talk me through your solution as you go. Now, for this part of the exam, you can use sorry, I got distracted. You can use whatever resources you want for this part of the exam. But the point is you're going to have to talk through and explain everything. So because you can use different resources, because you're going to look at the problem and then you can prepare the problem to show me, what you show me needs to be really tight in terms of explanation. There really shouldn't be any parts where it's like you're unsure about something or something like that. Okay, so let's begin. You would have the problem written down, but I'm going to tell you what the problem is. Sorry, somebody just came by my office. Okay. Oops. So let's say the problem is the following. I can't blame that on the canvas. Let's say the problem is the t derivative of u is equal to the double x derivative of u plus u, and we're given u of x0 is equal to f of x, and it says solve this using Fourier transforms, and you got to start from the beginning of Fourier transforms, like taking Fourier transforms at both sides and doing the procedure that we did in class. Okay, so if this is the starting point, so I haven't started my submission yet, so I'm going to sort of present to you, starting in just a moment, it'll be clear when I begin, kind of exactly what I'm looking for, and I'm not going to explain it in as much detail as I would with teaching. I'm just trying to give an example of what I'm sort of looking at you to do when you solve this problem. Okay. My name is Rob Ram. This is the video portion of my exam 1. So we begin with this equation and we take Fourier transforms of both sides. When I take a Fourier transform of the left-hand side, it becomes the t derivative of the Fourier transform. On the right-hand side, the Fourier transform of the double derivative is minus omega squared times the Fourier transform. And then the Fourier transform of u is just the Fourier transform of u. I can factor out a u hat, and I get minus omega squared plus 1 times u hat of omega t. And I notice that for a fixed omega, this is an ordinary differential equation in the t variable, and the solution is u hat of omega t is equal to u hat of omega 0 times e to the minus omega squared e to the minus omega squared plus 1 times t. But this right here is just the Fourier transform of the initial data. So this is just f hat of omega times e to the minus omega squared, and I can write this right here as e to the minus omega squared times e to the t. Now what I want to do is I want to take the inverse Fourier transform of this function right here. This doesn't have any omega, so as far as the Fourier transform stuff is concerned, that's just e to the t, it's just a constant. And now for this part right here, the inverse Fourier transform of this part is going to be 1 over the square root of 2 pi times the convolution of the inverse Fourier transform of f, which is just, the inverse Fourier transform of f hat, which is just f, and the inverse Fourier transform of e to the minus omega squared, and that's going to be e to the minus x minus y squared over 4t, and then this gets divided by, I can never remember what it is, the square root of 2t dy, and then this e to the t right here It just multiplies this, so we can do like that. And that is the general solution, or that is the solution to this PDE. Thank you. That was my exam. All right, so that was my exam. I timed myself. It took me a little over 2 minutes. I think in the instructions I say 2 to 3 minutes. So that's exactly what I'm looking for. That's the level of detail that I'm looking for there. Notice that I didn't prove the convolution theorem to go there to there, that sort of thing like that. I guess if I needed to be a little more precise, it would have been something like this to put the limits there. But this is the sort of thing that I'm looking for. I hope this gives you an idea of what I'm looking for the video portion.